Introduction. The term cloud is used as a metaphor for the internet based on how the internet is depicted in computer network diagrams and is an abstraction for the complex infrastructure it conceals. Cloud computing can be defined as an information technology (IT) paradigm that enables obtuse access to shared pools of configurable system resources and higher-level services that can be rapidly provisioned with minimal management effort, often over the internet. Cloud computing relies on sharing of resources to achieve coherence and economies of scale, similar to a public utility. Advantages of the cloud computing technology include cost savings, easy scalability, and high availability. Definition of cloud computing. Cloud computing is a model for enabling convenient, on-demand network access to a shared pool of configurable computing resources, for example, networks, servers, storage, applications, and services that can be rapidly provisioned and released with minimal management effort or service provider interaction. More currently though, cloud computing refers to the many different types of services and applications being delivered in the internet cloud and the fact that, in many cases, the devices used to access these services and applications do not require any special applications. Many companies are delivering services from the cloud. Some notable examples include the following. Google has a private cloud that it uses for delivering Google Docs and many other services to its users, including email access, document applications, text translations, maps, web analytics, and much more. Microsoft has Microsoft Office 365 online service that allows for content and business intelligence tools to be moved into the cloud, and Microsoft currently makes its Office applications available in a cloud. Salesforce.com runs its application set for its customers in a cloud, and its Force.com and VMforce.com products provide developers with platforms to build customized cloud services. But what is cloud computing? The following sections note cloud and cloud computing characteristics, service models, deployment models, benefits, and challenges. Characteristics. Cloud computing has a variety of characteristics, with the main ones being shared infrastructure. Uses a virtualized software model, enabling the sharing of physical services, storage, and networking capabilities. The cloud infrastructure, regardless of deployment model, seeks to make the most of the available infrastructure across a number of users. Dynamic provisioning allows for the provision of services based on current demand requirements. This is done automatically using software automation, enabling the expansion and contraction of service capability as needed. This dynamic scaling needs to be done while maintaining high levels of reliability and security. Network access needs to be accessed across the internet from a broad range of devices such as PCs, laptops, and mobile devices using standards-based APIs, for example, ones based on HTTP. Deployments of services in the cloud include everything from using business applications to the latest application on the newest smartphones. Managed metering uses metering for managing and optimizing the service and to provide reporting and billing information. In this way, consumers are billed for services according to how much they have actually used during the billing period. In short, cloud computing allows for the sharing and scalable deployment of services as needed from almost any location and for which the customer can be billed based on actual usage. History of cloud computing. Before we discuss the other topics of cloud computing, let's first see from a historical perspective where cloud computing fits in and whether it is really different or just the next fad. As figure shows, 6 phases of computing paradigms from dummy terminals or mainframes to PCs, network computing, grid, and cloud computing. In the first phase, dummy terminals are used to connect to powerful hosts shared by many users. At that time, the terminals were basically keyboards and monitors. In the second phase, independent personal computers, PCs, became powerful enough to satisfy users' daily work, which means that you didn't have to share a mainframe with anyone else. In the third phase, a computer networks that allowed multiple computers to connect to each other. You could work on a PC and connect to other computers through local networks, LAN, to share resources. In fourth phase, local networks were connected to other local networks to establish a more global network. Users could now connect to the internet to utilize remote applications and resources. In fifth phase, brought us the concept of an electronic grid to facilitate shared computing power and storage resources, distributed computing. People used PCs to access a grid of computers transparently. Now, in sixth phase, we can leverage all available resources on the internet in an extremely scalable and simple way by cloud computing. As figure shows, a conceptual layer, a cloud on the internet, hides all available resources, either hardware or software, and services, but it publishes a standard interface as long as users can connect to the internet. They have the entire web as their power PC. Cloud computing thus refers to the techniques that enable and facilitate this scenario. Layers of cloud computing. According to the abstraction level of the capability provided and the service model of providers, cloud computing services are divided into three classes: infrastructure as a service, platform as a service, and software as a service. As figure illustrates, the layered organization from the physical infrastructure to applications of the cloud stack. These abstractions levels can also be viewed as a layered architecture where services of a higher layer can be composed from services of the underlying layer. Why we use clouds? Better capital utilization. In the traditional model, you provision for peak loads or the maximum utilization. With cloud computing, you are charged on a usage basis. Note: the unit cost of on-demand capacity may be higher than the unit cost per time unit of fixed capacity. This is offset by not having to pay for the resource when not in use. If unit cost per time unit of fixed capacity is equal to C, utility premium multiplier for utility is equal to U, then unit cost of on-demand capacity is equal to U multiply C. Accelerate software development, deployment, and testing. Faster provisioning of resources is a key benefit in using clouds. Instead of taking weeks to set up the environment, it can be provisioned in minutes. Elasticity of resources. With cloud computing, you have access to a pool of virtualized resources that can expand and contract on demand. Access to complex infrastructure and resources without internal resources. Provision of infrastructure and application services can be outsourced to cloud providers. Support for geographically distributed users. Access to resources in the cloud are based on standard internet transports and protocols. New business opportunities. There are new business opportunities for providers to host cloud services and vendor applications. Service models. Once a cloud is established, how its cloud computing services are deployed in terms of business models can differ depending on requirements. The primary service models being deployed are commonly known as software as a service, SaaS. Consumers purchase the ability to access and use an application or service that is hosted in the cloud. A benchmark example of this is Salesforce.com. As discussed previously, where necessary information for the interaction between the consumer and the service is hosted as part of the service in the cloud. Also, Microsoft has made a significant investment in this area, and as part of the cloud computing option for Microsoft Office 365, its Office suite is available as a subscription through its cloud-based online services. Platform as a Service (PaaS). Consumers purchase access to the platforms, enabling them to deploy their own software and applications in the cloud. The operating systems and network access are not managed by the consumer, and there might be constraints as to which applications can be deployed. Examples include Amazon Web Services, AWS, Rackspace, and Microsoft Azure. Infrastructure as a Service, IaaS. Consumers control and manage the systems in terms of the operating systems, applications, storage, and network connectivity, but do not themselves control the cloud infrastructure. Also known are the various subsets of these models that may be related to a particular industry or market. Communications as a Service, CaaS, is one such subset model used to describe hosted IP telephony services. Along with the move to CaaS is a shift to more IP-centric communications and more SIP trunking deployments. With IP and SIP in place, it can be as easy to have the PBX in the cloud as it is to have it on the premise. In this context, CaaS could be seen as a subset of SaaS. Types of cloud computing. Although cloud computing has emerged mainly from the appearance of public computing utilities, other deployment models with variations in physical location and distribution have been adopted. In this sense, regardless of its service class, a cloud can be classified as public, private, community, or hybrid. Depending on the type of data you are working with, you'll want to compare public, private, and hybrid clouds in terms of the different levels of security and management required. Public cloud. Whole computing infrastructure is located on the premises of a cloud computing company that offers the cloud service. Public cloud is built over the internet and can be accessed by any user who has paid for the service. Public clouds are owned by service providers and are accessible through a subscription. Many public clouds are available, including Google Map Engine, GAE, Amazon Web Services, AWS, Microsoft Azure, IBM Blue Cloud, and Salesforce.com's. A public cloud delivers a selected set of business processes. The application and infrastructure services are offered on a flexible price per use basis. The call-out box in top of figure shows the architecture of a typical public cloud. Private cloud, hosting all your computing infrastructure yourself and is not shared. The security and control level is highest while using a private network. A private cloud is built within the domain of an intranet owned by a single organization. Therefore, it is client-owned and managed, and its access is limited to the owning clients and their partners. Its deployment was not meant to sell capacity over the internet through publicly accessible interfaces. Private clouds give local users a flexible and agile private infrastructure to run service workloads within the administrative domains. A private cloud is supposed to deliver more efficient and convenient cloud services. It may impact the cloud standardization while retaining greater customization and organizational control.